we have ourselves an exam question here, which is the velocity v of an object is given by the equation v equals at to the power 3 minus bt, where t refers to time. What are the dimensions of a and b? Our equation is v equals at to the power 3 minus bt. To summarize the law of homogeneity, it says that for an equation to be valid, the dimensions on the left-hand side have to be exactly the same as the dimensions on the right, meaning the dimensions of at to the power 3 and bt have to be the exact same ones as the dimensions of v. So we have to establish the dimensions of velocity, and we'll equate it to at to the power 3, and that's how we'll get the dimensions of a. We'll do the same thing for this second part, and we'll get the dimensions of b. With that in mind, let's get into it. Okay, so our equation v equals at to the power 3 minus bt. Let's first establish the dimensions of velocity. Velocity is equal to displacement over time taken. The dimensions of v, displacement is length and time is simply capital T. We can write this as LT negative 1, the dimensions of v. So that would be LT negative 1. We replace that there. This is equal to AT to the power 3 minus BT. Now, following from the law of homogeneity, the dimensions of velocity LT negative 1 have to be the same as the dimensions of AT to the power 3. Now let's also replace t with the actual dimension so that this equation becomes LT negative 1. The dimensions of time become t, but this is now to the power 3 minus bt. Okay, now let's get the first part. So we equate this one and this one. So that's LT to the power negative 1 is equal to AT to the power 3. So to get A, we simply divide both sides by t to the power 3. So that t to the power 3 and t to the power 3 cancel this side. This side we remain with LT. We can write this to the power 4. If the 3 goes on top, it becomes negative. Then we add the exponents. This is equal to A. So these are the dimensions of A. The dimensions of B, we equate LT to the power negative 1 to BT. We do the same thing. We divide both sides by t. Cancel t this side, cancel t. We remain with, on this side, this becomes LT negative 2 is equal to B. And there we have it, the dimensions of A and the dimensions of B.